on that. Okay, Kamala, you can take over on that.
Yeah, we are live now. Yeah, you can start. Meena, we are live now. Komal can start the session.
Oh, I don't believe I'm presenting. It's the AI workshop now.
Yeah, I'm presenting.
Okay.
I believe.
Sorry, just a minute. Yeah.
Okay.
1 minute. So while the participants are working, you can take a break and then you can do it. Komala said there would be another 5 minutes after this session. So that time you can continue. Now let's move on. So this is the intro to AI workshop. We'll move on to the intro to AI workshop now. Jury Long is a human-centered computing PhD candidate at Georgia Tech. She is a human-centered AI research interested in issues surrounding AI literacy and human AI interactions. Welcome, Jury Long, and take it forward.
Thank you. Can you all hear me all right?
Yes.
Great. Okay. So I'm just going to be giving you sort of a high-level introduction to what AI is. Today, whoopsie, sorry, guys. Working on the side. You already gave me sort of an introduction, but I just wanted to tell you a little bit about what I do before I get started. I work in the expressive machinery lab at Georgia Tech. I'm in the 5th year of my PhD program, hopefully, fingers crossed, graduating in May. And I do research on designing sort of collaborative, creative experiences with AI, particularly in learning environments like museums. So I'm interested in how we can make AI that can interact with us socially, improvisationally, and creatively in domains like dance or music, and how those interactions can be used to foster learning. As was mentioned, I'm at Georgia Tech in Atlanta. So I wanted to start off by talking a little bit about what intelligence is, because that's sort of foundational to what artificial intelligence is. There's like a lot of different sort of opinions about what type of intelligence we're trying to emulate or recreate when we create artificial intelligence. And some people feel, that we're trying to recreate human level intelligence. So the sort of general intelligence that humans need to interact with the world in their day-to-day lives. But other people, feel that sort of like the intermediary steps of maybe emulating the intelligence of a dog or an ant is sort of enough, or even, a really big challenge for AI developers even to develop, something with that level of intelligence. And there's a lot of different factors that go into intelligence. So factors like being able to communicate or having knowledge of the world, having knowledge of yourself, being able to do things with intention, so meaning to do something. Creativity is widely acknowledged, as an aspect of intelligence, as well as perception and motor response, which basically just means, you're taking in information from the world and you're responding to that. So you see that, in robots. And those are all different components of intelligence, and artificial intelligence, as we know it, sort of touches on a lot of these different components individually. But we've yet to see, an AI that, is able to do all of these things. Sorry, my slides are a little slow to transition. So one of the big sort of questions, just to define what exactly AI is, there's sort of a lot of debate and confusion over exactly what is AI and how is AI different from a regular computer program. And there's a lot of different opinions on this, but I think sort of the two basic things to take away is that either, an AI can learn, so it can sort of learn over time in a way that a regular computer program can't, or it can reason. And I think that's helpful to think about an example here. So if you're thinking about something that just, senses something and automatically gives a response, like a clap light, for example, you clap and a light turns on, that's not doing any reasoning. It's just sort of automatically, responding to the noise of the clap. Versus a similar device that might hear a sound like an Alexa or like a Google Home, a voice assistant, and then it has to reason about that sound in order to make a decision on how to respond. And that would be an AI because it has that reasoning component added in. And that's sort of one way to think about the difference between what AI is and isn't, and to be able to distinguish between technologies that do and don't use AI. I really like this flow chart by Karen Howe at where she drew this for the MIT Technology Review. It's sort of a flow chart that walks you through a decision tree of different factors you can consider to decide if something is AI or not. Can it move? Can it move by itself? Does it move based on what it sees and hears? Are you sure it's not moving on a pre-programmed path? And these things can sort of lead you to conclude whether the AI is able to reason or if it's just, a computer program that's not necessarily AI. It's just pre-programmed. But I think also that flowchart kind of shows that it can be confusing to determine whether something is AI. So we can kind of, I wanted to show a couple examples of technologies that use AI. You're probably familiar with a lot of these. Technologies that commonly use AI include like voice assistants, like Alexa or Google Home or Siri, smart or self-driving cars, or even regular cars with sort of smart car features like adaptive cruise control or like automatic, parallel parking or sign detection. Technologies like facial recognition, which is used both in, security applications as well as, apps like Snapchat or TikTok where you can put a filter on your face. Home devices, there's a lot of AI home devices like robotic vacuums and smart thermostats, as well as like smart home security cameras. And AI is also used in applications like Netflix or Amazon or Spotify to recommend movies or songs or products to you based on your past behavior. You also see AI in video games to control non-player characters, and in apps like Lyft or Uber to sort of do route planning. So there's a lot of different applications. Oh, I skipped this one, like a smart AI doll. A lot of different applications of AI. These are just a couple examples, but it should give you an idea of some of the places you might have seen AI before in your interactions. Oops, skipped a slide. So AI, a lot of what we see in like movies and TV is general AI. And this is AI that has sort of, I was kind of touching on this earlier, this general intelligence. So it's able to communicate, it's able to interact with the world, it's able to transfer knowledge that it learns in one area to a totally new area. And this is sort of the human level of intelligence that we see sort of approximated in, movies like Star Wars, where you see robots or droids that are able to function at a human or slightly subhuman level. But what we actually have, in the real world is narrow AI. And this is AI that can perform really well in one particular domain, generally. So maybe it's really good at recommending newsfeed posts, or it's really good at recognizing faces, or it's able to, vacuum your home. But if you try to transfer one of these technologies to a new setting, it's probably not going to perform as well. So if you try to take your Roomba, from vacuuming your apartment and you try to get it to, play around your backyard, it's probably not going to do very well, with the terrain. Or if you try to talk to your Facebook news feed, it's not going to be able to communicate with you like an Alexa would. So we have a lot of very specialized AI. And one of the big challenges for AI developers is figuring out, how to develop an AI that can work outside of a specific context or transfer knowledge to a different domain. So that's sort of a difference between the AI that you might see in popular media versus the AI that actually, exists in the present day. So there are some things that AI, again, sort of touching on what AI can and can't do. There are some things that AI is good at, and there are some things that AI is less good at. And this is sort of good to be aware of as you look to build AI. And it's not that you can't do the things that AI is less good at. It's just you need to consider that that's going to be a more challenging problem for you, or as a researcher, a more interesting research question to kind of pursue. So some things that AI is good at already is detecting patterns in data. So we'll talk a little bit more about that later, but looking at large amounts of data and being able to identify common patterns that occur across that data. It's really good, as I mentioned, at learning how to do a specific task. So working in a specific environment to do one particular thing. And it's really good at doing repetitive tasks. So if you imagine like a AI robot, working in a factory environment, it's able to perform repetitive tasks better than humans can. And as well as making decisions in controlled environments. A lot of times when you see like a robotic device, it's really good at doing its job in a particular environment. But if you were just to like set it out on the street and ask it to go, it might be more challenging for the AI to perform in that space. Some things AI is less good at, interacting naturally with people. Probably if you've ever tried to talk to, Siri or Alexa, you realize it does not talk like a human does. And sometimes you have to phrase your words in certain ways, and there are definite limitations to its communication abilities. And that's something that, AI researchers are working on, researchers who are interested in, natural language processing, as well as creativity are sort of trying to foster that. AI, as I mentioned, is less good at transferring knowledge to a new domain. And it's less good, or it's more challenging for AI to do tasks that require an understanding of creative or improvisational interaction or an understanding of human emotion. And that's not to say that projects that address these things don't exist. I myself work on developing creative AI, but it's a much more challenging problem to explore. So there are three main types of AI that I wanted to sort of present to you guys today. There are cognitive systems, machine learning, and robotics. And you've probably heard the most about machine learning and robotics. I feel like those are the ones that are talked about the most in public media, but we're going to talk about a few examples of each today just to get an idea of what the full field of AI looks like. So cognitive systems use pre-programmed knowledge or knowledge provided by a human programmer to think, and we'll talk about a couple examples of that in a minute. Machine learning, in contrast, learns how to think by looking at a lot of different examples. And robotics involves intelligent devices that are able to interact with the physical world. And robotics kind of intersects with machine learning and cognitive systems because it may use machine learning or a cognitive system or a combination of the two to reason about things in the world. So if you think about a robot as the physical device that senses to and responds to the world, if it's doing any reasoning based on like a camera that's attached to it, for example, that reasoning may be done using machine learning. Or if it's planning, how to get from point A to point B, that reasoning might be done using a cognitive system. So I wanted to walk through a few examples of what a cognitive system might look like. This is an example of a knowledge representation, which is basically just a fancy word for a way that a computer stores knowledge. So think of this like our memory, for example. And this is an example of one type of knowledge representation called a semantic network. And in a semantic network, you sort of connect objects and ideas. So you sort of program this network into the computer, and you can tell the computer things like a cat has fur, or a cat is a mammal. And then if the computer is asked questions about what a cat is, or it's asked to generate something related to a cat, it can respond, oh, a cat, it's a mammal that has fur and eyes and it dislikes birds. So this is one way of sort of pre-programming knowledge into a computer. But obviously you can run into some issues of scale. It's really hard to establish like a broad knowledge base for a computer using this, although a couple do exist. WordNet and ConceptNet are some examples. Another example of knowledge representation that's used in cognitive systems is a decision tree, which you might have seen before, where you sort of have this tree of questions and branches, and the computer can sort of reason by, you know, if you ask, you know, is a bird, what is, you know, an animal that lays eggs, you can sort of traverse this tree and say, oh, does the mammal breathe air? Yes. Does the mammal lay eggs? Yes. Oh, it's a bird. And use this representation to reason. So the next type of AI I want to talk about is machine learning. And machine learning learns by looking at a lot of different examples. So in this example, you might show machine learning a lot, like a machine learning algorithm, a lot of pictures of cat and a lot of pictures of dogs, very different pictures. And then it's able to determine, you know, based on the next picture you show it, whether that picture contains a cat or a dog. So instead of pre-programming knowledge like you would in a cognitive system, you're showing it a ton of examples. You're saying, this is a cat, this is a cat, this is a cat. And from that information, the computer learns, you know, what a cat looks like. And finally, robotics, like I mentioned, are these, you know, physical devices, but they might use machine learning or cognitive systems to reason. So I was told that you guys are kind of focusing a little bit, maybe more on machine learning. So I wanted to sort of delve a little bit deeper into machine learning in the remainder of this talk to give you guys a little bit deeper level understanding of some types of machine learning that exist. So there's three main types of machine learning. The first is supervised learning. And there are a couple of different sort of subtypes of supervised learning. One type of machine learning algorithm is a classification algorithm. And this is kind of the one that I just talked about with the cat and the dog example. So a classification algorithm is able to say, yes, this is a cat. No, this is not a cat. You know, yes, this is a bird. No, this is not a bird. It's able to answer sort of like yes or no questions, or classify, you know, images or songs or a variety of other things based on their type. So you might see this, for example, in like a facial recognition algorithm is able to classify faces as belonging to a particular person or group of persons. A regression algorithm is another example of supervised learning. And a regression algorithm is what you might see on, you know, like social media, like Facebook or TikTok or Instagram. And this type of algorithm uses past data to make a prediction about the future. So in the social media example, it might use past data about social media posts to make a decision about past data about what you viewed on social media to make a decision about what to show you next. So that's supervised learning. The next type of machine learning is unsupervised learning. So this is where you don't tell the computer anything about the data up front. You're not telling the computer this is a cat, this is a dog, and then having it learn from that and be able to answer the question. You're just showing it a lot of data. And the computer uses a model to try to group that data in a particular way. That's why it's called unsupervised. So an example of this would be, imagine a program that groups songs based on genre. You might show it, but it doesn't know all the genres that exist. It doesn't know that, you know, there's rock and there's pop music and there's hip hop music. It's just shown like a bunch of songs. And the computer tries to find, you know, similarities between these songs and might break them into different clusters. And the clusters might be grouped based on human genres, but they might also be based on similarities that the computer saw that we didn't necessarily, that don't necessarily, you know, match up with a human definition of a genre. But that's an example of unsupervised learning algorithm. And the third type of machine learning is reinforcement learning. And I always think of this sort of like training a dog. So the agent is going to do something and you're going to give it a reward if it's doing the right thing. And sort of through that iterative process of doing something and then telling the agent whether it did the right thing, the agent will sort of iteratively learn what to do. So there's sort of a whole life cycle to developing a machine learning program, and I'm not going to talk about all of it in a lot of detail today because we don't have time, but I wanted to touch on a few aspects at a high level. I'm going to talk to you a little bit about the process of gathering and preparing data, training a model, and then testing that model. So first, I want to talk a little bit about what exactly what data is and what a data set is. So data can be really, anything that you think about. Data can be an image, or it could be numbers, or it could be songs, or text messages, or emails, or Facebook posts. Any of those things can be are a piece of data. And a data set is a collection of a lot of different pieces of data. So it might be a collection of images of a certain type. So maybe you have a collection of, continuing with my example, of images of animals. It could also be a collection of tweets or Facebook posts. It could be a collection of a lot of different songs if we were, using the genre clustering algorithm I talked about earlier. We're a collection of a lot of different emails or text messages. So you can kind of think about, any information that you might be sort of sharing on a computer. You could imagine sort of putting together a data set of that information. It could also be a collection of people's names and birth dates, for example. But data is usually a little bit messy when it comes to you. You can imagine a lot of different problems in a data set that maybe you gather by scraping websites, or even just gather, you put a bunch of songs together in a database. And there's some things that you want to make sure to do to your data to prepare it to use in a machine learning algorithm. So most obvious is you want to clean it up. So say there's blanks in your data, or some things that, aren't formatted in the same way. You have to sort of clean that up. You also may want to randomize the ordering of your data. So your machine learning algorithm, doesn't learn things based on the order in which they're presented to it. Something that's really important is correcting imbalances in your data. So I think the previous speaker might have touched on this a little bit in her discussion of ethics, but it's really important, if you show a computer only one particular type of data, it may become biased towards that type of data. So in the example of, teaching a computer what a dog is, if you show the computer only pictures of Labradors, and then you ask it to identify dogs in general, it's going to probably be pretty bad at recognizing a dog like a Boston Terrier because it's never seen one of those before. So you really want to make sure your data is well balanced and includes examples, a wide variety of examples, because this can lead to, pretty big issues with things like facial recognition algorithms. If they're not trained with, enough diversity in the data set, they can develop bias and not be as good at recognizing certain groups of people, for example. You also want to split up your data. So I'll talk a little bit more about that in a minute, but you want a training data set and a testing data set. And there's a lot of other things you can do sort of in the process of data preparation, but I just sort of want to emphasize that you don't just get a data set and go with it. You sort of have to give some attention to processing the data. And you also have sort of the step of analyzing the data, which I'm not going to talk about as much, but you analyze the data in order to be able to choose a model that fits your data and purpose. So an example of this would be you're wanting to, classify animals from a data set of images, and you might choose a model of a particular classification algorithm that takes in images of animals and outputs the type of animal in the image. And in order to train that model, you're going to show some of your data to the model to teach it, and you're going to tell it, this is a cat, this is a dog, this is a bird. So you're going to give it the right answer. And from that information, you're going to train your model. And then you'll have a model that then you can test. So when you have a final model, you will want to show it new data and see how well it does. So this is sort of why you want to split your data set up. So you can show it an original set of data, and then you can show it a new set of data to test how well it does. And if it does well, that's great. It's a model that's ready to be used in the world. But if not, you may need to go back and retrain it and consider why it didn't do very well and what you need to do differently in terms of your data set or the model that you chose in order to make it perform well. I also just really wanted to emphasize the importance of when you're building an AI to consider the limitations that it has. I think a lot of, the issues that we hear about with, AI programs are often due to thinking that, AI can do it all. And it can't. And it's important to think about, when you're putting a product out there in the world, what is it really good at doing and what isn't it very good at doing? So, and also important to think about what it should be used for and what it shouldn't be used for. Considering any negative uses that could possible negative uses of your AI technology and what you might do to prevent those from happening. I also think it's really important, and I think the previous speaker touched on this a little bit as well, to think about who your AI is designed for and who it excludes. And this goes not only to the question of like a biased data set, which I was talking about earlier, thinking about what type of data you're including and who that's allowing, what that's representing in your algorithm. But I think it also goes to thinking about sort of from a design perspective, which is the space where I work a lot, is thinking about, who are you designing this for? Who's going to be using this AI? What are their needs? And how are they going to be using it? And who, is not going to use your AI because of the way that it's designed. So I think these are all just really important limitations to consider when you're building an AI device or program. And I know you guys are sort of looking towards building and developing AI. And I think some important things to think about when you're considering what you want to build or develop is to think about what a problem you would like to solve is, and to start simple. So, don't start with trying to, solve world hunger through AI. Think about a simple problem in your life that you think would be made easier or solved by an AI program, and build something and try it out and see how that works. It doesn't have to be, super complicated or a giant thing to be a really cool project. And then, as I suggested, consider its limitations, consider how it could be improved, and consider, what its specific purpose is, within the broader scope of things. So I hope that gave you guys sort of an introductory high-level overview of what AI is. And I hope you guys get to dig, a little bit more into that over the course of the hackathon. But I would be happy to take any questions you guys have about AI or me and what I do. Yeah. I don't know how you all want to do questions.
What made you consider into going into design? Oh, this is Chelsea from the Annie Easley team, by the way.
Hi, Chelsea. I did my undergrad in computer science. I actually started off as a math major and a theater major. And I took a introductory CS course for the math major, and I really found myself drawn to I really liked the logical aspects of computer science, but I felt like I was able to see sort of more like immediate impact and results of what I was doing through computer science rather than math. And I was really interested in going into research in some form. I actually ended up applying to graduate school in math as well as theater. And I ended up sort of going the computer science route because I found a lab, which is where I'm working now, the Expressive Machinery Lab, that sort of combines the aspects of like creativity that I was really interested in with computing. And that's sort of how I ended up where I am now, doing research and computing. Yeah.
Oh, and I have another question.
Uh-huh.
Do you ever feel like being in the CS industry, like, do you ever feel like your creativity is limited, or does it enhance that?
That's an interesting question. I actually oftentimes feel like you're able to be really creative with code, but I think you have to, find the right space that allows you to do that. So I think there are a lot of coding is a really creative activity. You're able to create things, you're able to come up with an idea and sort of make that happen on a computer, which is something I think that's like pretty unique to computer science, and is a cool aspect of it. But you have to find, an environment that supports that. I know sometimes when you're taking like a computer science course and your assignments are sort of like mandated or handed down to you, it can feel a little bit less creative if you're not getting to sort of come up with your own directions. But working on side projects and exploring your own personal creative ideas, I think can be a really good way to make sure that you're getting to have that aspect of creativity in your coding practice. And I think that the previous speaker mentioned like P5JS and processing are two really great programming environments that allow you to do creative things like with music and visualizations that it sort of bootstraps that programming experience, so you can sort of make more interesting creative technology without all the overhead. And I think looking at environments like that can really help as well.
My name is Elizabeth, and I am from the Hector Garcia Molina team. And what's your favorite part about your job?
Oh, hi, Elizabeth. Thanks for your question. Favorite part about my job? That's a really good question. I would say two things. I really like the research aspect of it. So I really enjoy being able to think of an interesting question and then come up with a plan to be able to investigate that question. And that's something that I find really exciting. It definitely like brings in that aspect of creativity, and I think is I think there's a lot of advantages to like a career in both industry as well as academia. But I do think that's one of like the strengths of academia is giving you that freedom to sort of explore questions of interest to you. And I like the process of sort of like reading and writing and coming up with ideas and sort of formulating them into arguments. But I think I've also sort of my second answer to that question is I've realized this year, especially, we've working from home and not getting to enjoy sort of the social aspect of my career. I really miss that. And I think one of the things I do enjoy most about my job is like being able to work in a lab with like a bunch of other people who are working on cool projects and have those collaborations with people and attend conferences and being able to sort of talk with people and share ideas. That's also something I think I really have come to realize, especially this year, that I really enjoy about my job.
Thank you.
Yeah, thanks.
This is Tanya from the Katherine Johnson team. So I was wondering what like the hardest part of your job is.
That's a good question. Hardest part of my job. I think one of the hardest things about being in an academic environment is the lack of sort of a concrete defined work schedule. So, doing a PhD, it's a lot of self-structured time. So you sort of have these big milestones that you're supposed to reach. I just finished submitted my dissertation document earlier this week. But that's one of like the big milestones, but you're not necessarily given a roadmap for how to get there. And you have to sort of plan your own schedule from how to get to point A to point B, and how to, structure your day. You don't have sort of the 9-to-5 work schedule that you might have in an industry environment. And I think that can be really challenging, both because it's hard to stop working. You can sort of let work bleed into all aspects of your life, and it's harder to establish that work-life balance, which I think is really important to do, and is something that I am still working on, doing. And, but I also think it can be hard, to stay on track to meet a deadline, for example. It's really easy to sort of get behind if you're not sort of managing your schedule carefully. I think that's one of the most challenging parts for me, at least, of what I do.
Okay, thank you.
Thanks.
Okay, so thank you very much for the great explanation for the kids, and then I hope they really had some good knowledge about the session. So moving on, Komala, you want to take up 5 more minutes for the kids to wrap up and then post their activity that you had given?
Yeah, sure. That sounds good. Feel free to keep working if you haven't posted already. I will go ahead and share my screen to just share some of the submissions. I am super impressed with how creative everyone is. Let me share my screen over here. So we had someone attempt the unicorn dab, which was super amazing. Well done in such a short amount of time. Another one over here, also very creative. And I love seeing everyone just appreciating each other's posts, because wherever you go in your career, whether that's data science, whether that's AI, whether that's product design, marketing, whatever, it's really important to build that camaraderie with your team and really appreciate each other, because that's how collaboration happens. That's how teamwork is. That's how teams are built, and mutual respect is built for each other. So wonderful job, everyone, just celebrating each other's art. I love this bird over here. So peaceful. We got a dinosaur, I think. This is the coolest Mona Lisa I've ever seen. Wow. It's a lot of swag over there. Very nice, very nice. Feel free to keep adding your submissions, getting those creative juices flowing. We have another workshop, and then we'll get straight to your design thinking. So this is a good way to just get ready.